Hey guys, this is Mr. Gran, 8.2 multiplying and dividing rational expressions. In this video, we're going to be multiplying the rational expressions. So, these are our steps for the majority of the problems. We'll see the exception to this, but most of the problems you're going to be doing, you can follow these steps. Start out by factoring all parts completely, just like simplifying. Multiplying rationals and dividing rationals is pretty much the same as simplifying with just like one extra step. Once we have everything factored, we will cancel the common factors. And then the last thing for multiplying is we'll multiply across. So real quick, how do you multiply a fraction? Let's review that. 3/4 times 1/2. You multiply the numerators and the denominators separately. So the numerator is 3 times 1, which is 3. The denominator is 4 times 2, which is 8. That's how you multiply fractions. Okay, so our first two examples. We've got one that's sort of the exception to the rule that was in the previous slide. This is really just exponent rules is all it ends up being. But it fits here because they're fractions. And then this is the one that the last slide refers to. Okay, so when it comes to these, you can certainly, some students like to reduce each one separately and then multiply it together and then reduce it again. I find that it's a little less work if I just put everything together first and then reduce it once, so that's how I'm going to do it. Okay, so what that looks like. 3 times 10 are coefficients, make 30. X to the 5th and x cubed is x to the 8th. You remember you add the exponents. Y to the 3rd and y to the 4th, y to the 7th. Then for the denominator, 2 times 9 gives us 18. X cubed times x squared gives us x to the 5th. And y to the 7th times y to the 5th is y to the 12th. All right, now I'm just going to reduce everything. I like to think about it this way. Reduce your coefficients, and then reduce your matching variables. So reduce your x's, reduce your y's. Kind of split it up, and then it's a little less overwhelming, I feel like. Okay, 30 over 18. They're both even, so we could reduce them by 2. They're both divisible by 3, so we could reduce them by 3. If we want to do it in one step, though, the GCF of both of them is 6. So if I divide both the 30 and the 18 by 6, I get 5 over 3. All right, then the x's and the y's, just our exponent properties, 5 from the bottom, cancel 5 from the top, and we've got x cubed left over. And then in this case for the y's, the bigger ones on the bottom, right? So these 7 on top are going to cancel 7 from the bottom, and we get y to the 5th. All right, with these, what we're going to start is by factoring them, right? Looking at this, x minus 3, x plus 5, those ones don't factor. But the 4x plus 20, that's got a GCF. I can reduce that, take out the 4, and it is 4 times x plus 5. Takes care of that one. X squared minus 9, this is our difference of squares, so that's plus 3 minus 3. Right? They multiply to a negative 9 but cancel each other out. And now I just have to cancel the common factors from the top and the bottom. I've got an x plus 5 on the bottom on this side and x plus 5 on the top here. You can cancel across a multiplication sign. Not across a division, not across an addition or an equals or anything like that, but you can cancel across a multiplication. All right, then x minus 3 on top here cancels the x minus 3 down here, and that's all the canceling I can do. Everything canceled on the top of the fraction, the numerator. That doesn't make it go away or make it 0, it makes it 1. And then what's on the bottom? 4 times x plus 3. And for this, we can leave it in its factored form. You could distribute the 4 through and make it 4x plus 12, but we can just leave it in its factored form for these ones. Oh, also notice, it says assume that all expressions are defined. That's why I did not finish this by saying that x can't equal a negative 3 or a positive 3 or a negative 5 or anything like that. If it says this, it's good if you're kind of thinking that, like where, what are our domain restrictions? But if it says assume that all expressions are defined, you don't have to worry about that. All right, here are some good ones to try on your own. Pause the video and then resume when you want to check your work. Okay, so the first one, just like the first one from the last slide, 2 times 6 is 12, x to the 4th times x is x to the 5th. And then the denominator, 5 times 3 is 15, x squared times x cubed, x to the 5th. Again, I'm going to think about this in two parts, right? The 12 and the 15, they are both divisible by 3. And so that gives us 4 over 5. And then the x to the 5ths totally cancel out, so there's no x's left. It's just 4/5. All right, with these ones, this is a little bit bigger than the one on the last slide, but it's not that much tougher. It's just more stuff, right? Just focus on factoring one piece at a time, right? Looking at this, factoring it. What multiplies to positive 4 adds to a negative 5. That's going to be minus 4 and minus 1. Not so tough. Looking down here, GCF, 3 and 12 are both divisible by 3. X squared and x, I can take an x out of both of those. And that's going to leave me x minus 4 on the inside of the parentheses. Up here, we've got a GCF, 2 times x squared plus 1. Not a difference of squares, right? This isn't factorable unless we use complex numbers, which we're not going to do. And then this one multiplies to negative 7, adds to positive 6. That's going to be a plus 7 and a minus 1. All right, so all of them are now factored, right? I just need to find common factors to cancel. So I've got an x minus 4 on the bottom that cancels this x minus 4 on the top. And x minus 1 here cancels this x minus 1. And I think that's it. There's nothing else matching from the top to the bottom that can cancel out. So my final answer for this one on top is the 2 times x squared plus 1. And in the denominator, 3x times x plus 7. And again, we'll just leave that in its factored form. All right, last one. We've got a GCF here, 4 times x plus 4. We've got a GCF down here, 2 times x plus 3. Multiplies to negative 3, adds to positive 2, plus 3, and minus 1. And then the x plus 4, that doesn't factor at all, so we'll just leave it. All right, what cancels? This x plus 4 cancels this x plus 4, top to bottom. This x plus 3 cancels this x plus 3. And what I have left, now I'm going to do this in two steps, right? I've got a 4 over 2 that's going to reduce, but I'm going to show that in the next step here. So my numerator, I've got a 4 and an x minus 1 that didn't cancel. And then on the denominator, all I have left is a 2. Well, then that 4 over 2 can still reduce, right? 4 divided by 2 is 2, so this is 2 times x minus 1.